Hi everyone, this is Mrs. Van Horn and this is the first recording from the lesson of IM2 Distance Learning Week 6. The objective for today is that you will be able to use part-for-whole relationships of central angles flexibly, so you'll be able to explain what is a chord and an inscribed angle and what special properties they have. Weekly quiz. Today's weekly quiz you're going to have is going to be on finding the equation from the graph with table of data. We'll also have a challenge problem where you are asked to convert standard form to a vertex form. Next week's quiz will be on area circumference of circle. Actually, I am going to assume that you know them. And so I am going to be quizzing you on sector area, arc length, central angle, and inscribed angle. So basically, it's last week's lesson and today's lesson. I'm going to start with warm-up problems. So the warm-up problems was the same as last week's problem, but I am going to go through it again. So please pause the video at this point and try to solve this yourself. Okay, I am going to assume you've had a chance to do this yourself, and I'm going to show you how I would solve this. So I am asked to write a quadratic equation given a graph for the first time. Okay, it's probably the easiest way is to, since we know the vertex, what's the vertex? Vertex, the coordinate is -3, -3. That means h is -3 and k is -3 in the vertex form. So the vertex form of quadratic equation is y is equal to a times x minus h all squared plus k. So I know that h is -3, so notice I am putting -3 here in parentheses so that I do not lose a negative, plus k. So at this point, I've written the two negatives here. So at this point, just to make it simpler for myself, I am going to change them both to positive, positive, because the negative, negative is same as positive, positive. So that simplifies to a times x plus 3 whole squared plus what's k? It's -3. Okay, well, I could have just written -3 like that. Alright, now we have the basic form of the quadratic equation, but we do not know what the a value is. So we need to figure that out. And how do we do that? Well, you can use any of the points that you know clearly from the graph. Looking at this, can I use x-intercepts? It's kind of in between -1 and -2, -4 and -5. So these would not be good points to use. But instead, let's see where the graph crosses the grid exactly. And I see that here it's crossing exactly. So I could choose this point. I see another point right here. Maybe I could have used this point and this point. I am choosing those points because the graph intersects the grid exactly where it crosses. So I know the exact point. I don't have to just guess, oh, it looks like 1.5 or 1.25 or whatever else. So let's just choose this number, this coordinate here. So this will be -2, -2, -2, -2. So that means I am going to substitute -2, -2. So -2 is the x value, -2 is also the y value. I could have chosen this, where this will be -1, 1. Or I could have chosen this, which is -5, 1. But I just chose this. Doesn't really matter as long as you're being consistent. Okay, so y is -2, so -2 is equal to a. We still don't know what a is. And x plus the x value is -2 all squared plus k is -3. Okay, let's simplify this. I made a mistake, haven't I? Oops, I've made a mistake, but I'm not just going to redo the whole video recording. I am just going to erase that. So negative 2 is my y value, so I'm going to substitute negative 2 here. A we still don't know. X, we're going to put negative 2 as my x, and then plus 3 from the equation. And then minus 3 is what we have from here. Okay, then from here, the right hand side simplifies to a times, what's negative 2 plus 3? That's 1 squared minus 3. Negative 2 is equal to that. So that is just 1 squared is just a. A minus 3 is negative 2. So I'm going to add 3 to both sides. So that gives me a is 1. Therefore, then I can say the equation is y is x plus 3 all squared minus 3, because I know a here is 1, so I can just rewrite it as it is. Okay, so that was the first problem. Let's do the next problem. Okay, this time I'm given a table of points. So how do I figure this out? Alright, so notice that parabola is always symmetrical. So if okay, you can see very well. Alright, notice the parabola is always symmetrical. That means that y value is going to be same here, y value is going to be same here. And we can do the same thing with the table of data. So let's match up the y values. I have negative 3 and negative 3 here, positive 3 here, and a positive 3 here. And that means the lona right in the middle, this is my vertex. And x value is 3, y value is negative 5. And therefore, we can use the vertex form again. Y is equal to a times x minus h. H is going to be, this is my h value, horizontal shift. This is my k value. So h minus x minus 3 whole squared. K is negative 5. So from here, now I get to choose any of the xy combination. I can choose 1, 3, 2, negative 3, 4, negative 3, 5, negative 3, or 6, 13. You do not choose this because you've already used this to come up with the equation. So you do not choose this. You need to choose any other point. So in that case, I can say y is, let's just go with the first one. So substitute 1, 3. Remember, this is going to be my x. This is going to be my y. So y is 3 is equal to a times x is 1 minus 3 all squared minus 5. 3 is equal to a times 1 minus 3 is negative 2 squared minus 5. Okay, now negative 2 squared, this is not negative 4, this is negative 2 times negative 2, so that's positive 4. So this becomes 4a minus 5 is equal to 3. Add 5 to both sides, then you get 8 is equal to 4a. Then from here, I am going to divide both sides by 4. And this leaves me with a is equal to positive 2. So y is 2 times x minus 3 all squared minus 5. And that's my solution. Okay, so I hope you're able to do this correctly.